So now let's move on and go through some use cases. We'll start by analyzing volume data. So what I mean by volume here, I'm talking about social media volume. So this can be the total number of likes, comments, shares, etc. Alright, so and this is basically data extracted from Brandix, and you can see here the conversational volume around Ronaldo. So this is when people are mentioning Ronaldo. Okay, it's broader than just liking or sharing a post. It's every time someone also uses a Ronaldo-related hashtag. Okay, and you can see a few interesting things happening in this time series, right? So you see that it starts low, then there's a spike, then it converges to another level, there's another spike, etc. Okay, so as you might have guessed, spikes are important, right? Because it means that something happened there. So ideally, we'd like to be able to detect those spikes automatically and also drill down into the data and understand what happened. Okay, if you have just one player, obviously you can just visualize the time series and see what's happening. But what if we had hundreds, right? So this is when things get more complicated and we need to look into more advanced methods. And more specifically, we're going to look into anomaly detection for the automated detection of spikes, and also going to look into natural language processing for detecting conversational patterns. So anomaly detection is the search for items or events which do not conform to an expected pattern. Okay, so it's very important to understand that this is very domain specific. Okay, so it's not easy to say that, okay, this is what anomalies look like in all different events. And now we're talking about time series, but there are other types of anomalies as well. So another very common example of anomaly detection is intrusion detection, whether someone is trying to hack into a server. Okay, so other domains is fraud detection, fault detection, system health monitoring. So you need to track someone's health and understand whether something's off the charts, basically, sensor networks and others. It's often used to pre-process anomalous data in order to remove it from the data set, since sometimes in supervised learning removing outliers can actually help and improve performance. But in our case, that's not what we care about. What we care about is actually detecting those anomalies. So there are a few different types of anomalies: point anomalies, contextual anomalies, and collective anomalies. And we'll discuss about each one in turn. So point anomalies describes a scenario where an instance is anomalies with respect to the rest of the data. Okay, so this is the simplest type of anomaly, and this is what most people refer to when we're talking about anomaly detection. So if you're trying to detect, let's say, credit card fraud, then point anomaly is what you're trying to do, right? So you have, let's say, someone's credit card transactions, and then suddenly you see a transaction from some faraway land, which is, very high. It's like a very large transaction, and this is automatically flagged as an anomaly with respect to the rest of the data. Okay, so this is also a visual graph to understand what's happening. So you can have, for example, a circle of, let's consider normal behavior, and anything that falls outside of this is an anomaly. Likewise, in a network context, there are some nodes which sit in isolation, and this is an anomaly within a network. Contextual anomalies are a bit different to point anomalies in the sense that they utilize the neighborhood or the context of a particular instance. Okay, so for example, if you're dealing with spatial data sets, okay, the longitude and the latitude are contextual attributes. In time series, maybe the position of an instance or the time, the particular window in time is the context, right? So this is interesting for our case because, for example, in social media spike detection as well as in intrusion detection, we care about the context in the sense that we're trying to detect bursts in activity. So if, for example, someone has 50,000 mentions on social media every day, then that's not anomalous behavior. What's anomalous is someone having 10 mentions every day and then suddenly spiking to 1,000, right? So that's another example of anomaly detection in time series. So here you can see the search volume for the term puppy, okay, and you see that it spikes pretty much every January, right? So if you, as you can see, the level of the spikes can be different, but what's important is that with regards to the context, with regards to the next of the year, there's a very large volume for this search term that run those days. Finally, we also have collective anomalies, and this is a collection of instances, which is anomalies with respect to the whole data set. Okay, so the individual data instances might not be anomalous by themselves, but their occurrence together is considered anomalous. So there are two main variations. One is that maybe events come in unexpected order. For example, if you're in a time series, you're analyzing ECG, maybe the ECG rhythm is not the right one, okay, or maybe you have unexpected value combinations. For example, in fraud detection, maybe one purchase is not, something interesting on its own, but maybe multiple somehow start looking a bit weird. There are many different techniques for anomaly detection, and some techniques that have been proposed are the ones which we can see here in the bullet points. So there are distance-based techniques that basically try to measure whether something is an outlier by comparing its distance to the neighbor source or some center. There are also support vector machines extension to outlier detection. Also neural networks. You can do the same thing with cluster analysis. And also you can do the same thing with association rules. So there are many different methods, as you can see. However, within the context of time series, a very good method which was developed by Twitter and also released as an R package is the Twitter anomaly detection package, which was created specifically for this kind of job, right? For detecting spikes in mentions on Twitter. So this method builds upon the generalized ESD test for detecting anomalies, and ESD stands for extreme studentized deviate test. So basically it uses robust statistics to understand what the median and the deviation around the median looks like, and then it tries to understand whether there are any points which deviate from what it considers standard based on the calculated statistics. In Twitter, expand the technique by also applying some seasonal decomposition in order to remove seasonal components, which can affect the process in time series. So you can have a few different parameters, such as the max number of anomalies. You can have anomalies in both kinds of directions, positive or negative, and you can also choose obviously the significance level and also the period of